it will act as a sink of electrons, right? Or it can act as a source of electrons, which gives away the electrons or which accepts the electrons, but it do not take part in the chemical reaction. Other than that, it is aqueous sodium chloride, so water is also present, hence H plus and OH minus ions will be also present. Apart from that, also Na plus and OH minus ions is there, right? So that together forms NaOH. So a total of 3 products is there: sodium hydroxide, chlorine gas and hydrogen gas is liberated. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with session 4 of the chapter Electrochemistry. So in the last session, we discussed and studied about the thermodynamics of Nernst equation, right? And as well, we started with electrolytic cell. Right, we also studied about the different applications of electrolytic cell as well. So in today's session, we are moving on with electrolysis, that is products of electrolysis. So when electrolysis is happening, that is in electrolysis cell, what will be the products which will be formed? Okay, so why we are studying about this is, so we are going to study about the different products that are going to be formed during electrolysis. Okay, so let's see, there are few factors on which what product will be formed depends on. Okay, so let's see, it depends on the nature of the material being electrolyzed and the type of electrodes which is used. Okay, so the products formed in electrolysis depends upon the nature of the electrode. What electrode we have taken, yes, which metal or what electrode we have taken, it depends on that, as well as on the nature of your electrolytic solution. Right? Yes. The next one is if the electrode is inert. Okay. If the electrode is inert means what? It won't be taking part in any reaction. So if you are taking the electrode which is an inert electrode, then it does not take part in the chemical reaction. Okay. And also acts as a source or sink of electrons. That means it will act as a sink of electrons. Right, or it can act as a source of electrons which gives away the electrons or which accepts the electrons, but it do not take part in the chemical reaction. Now if the electrode is reactive, it participates in the reaction. Right, now the products of electrolysis depends on the different oxidizing and reducing species present in the electrolytic cell and also on their electrode potential. Okay, so it depends upon which electrolyte solution you are using. Okay, so based on that, your oxidizing and reducing agents and oxidizing and reducing species will be different, right? So based on that, the products will be formed. Okay, now some of the electrochemical processes, although feasible means although it can happen, feasible means it can happen, the reaction can take place. Okay, so some electrochemical processes, although if those reactions can take place, they are so slow kinetically, that means the reaction happens extremely slow, that at lower voltages these do not seem to take place and extra potential has to be applied. So these reactions are feasible, but what happens is they are extremely slow. So once they are slow, what happens? We feel that the reaction is not even taking place. So to make this reaction much more faster and make this reaction to happen, we have to apply an extra potential which is called as over potential in certain cases when the reaction is feasible but it is extremely slow. So these are the factors on which the products of electrolysis depends. So let's take an example and understand what exactly we are going to study here. Okay, so first let us understand the electrolysis of sodium chloride. So what we are going to do now is we are going to take sodium chloride and make it undergo electrolysis. So what sodium chloride we are taking? It is electrolysis of fused sodium chloride. And after which we will be studying the electrolysis of aqueous sodium chloride as well. So the first one is electrolysis of fused sodium chloride. Fused sodium chloride means it is in molten state. That means there will be no presence of water here. Okay, sodium chloride in the molten state is called as fused sodium chloride, wherein there is no presence of water. Okay, so sodium chloride is made of which ions? Na plus and Cl minus ions. So there are only 2 ions in here, Na plus and Cl minus. So the products will be formed only with these two ions, right? So what will be the process happening here? So during electrolysis, we have already studied that there will be deposition or else liberation of any gas or any substance at the electrodes. So as you can see here, now we have only taken molten sodium chloride, that is no presence of water. So Na plus will be positively charged and it will move towards the negatively charged electrode. Which is the negatively charged electrode? It will be cathode, right? And positively charged electrode is anode, to which the Cl minus will move. So as you can see here, there are only two reactions that is taking place. One is the oxidation reaction and one is reduction reaction. So the first reaction you can see here is Na plus ions accepts electron and becomes Na solid, right? It becomes or it is deposited as sodium in the solid state. So Na plus ions, which is in the molten state, accepts electron and Na solid is formed. Sodium solid is formed. So accepting electrons, what reaction is taking place? Reduction, right? So reduction is happening in the first reaction. So reduction will happen in which electrode? Cathode or anode? Yes, it will take place in the cathode. So this particular reaction is taking place in the cathode and sodium will be deposited here. Sodium will be deposited on your cathode. Clear? It is negatively charged electrode. Now moving on to the anode, wherein oxidation takes place. Right? Cl minus ions gets oxidized into Cl2, that is chlorine gas. Right? So now in the anode, as you can see here, the bubbles, right? What is those bubbles? Chlorine gas is liberated. Cl2 gas is liberated in the anode and sodium is deposited in the cathode. So which two products are formed here? Sodium, which is in the solid state, which is deposited in the cathode, right? So now we saw the anodic reaction and the cathodic reaction. So how do I write the overall reaction? The overall or the net reaction. Overall net reaction will be, so how can I write the overall reaction? Yes, in the first reaction, which ion is present? Na plus. Yes, Na plus is getting reduced into Na. And in the second reaction, it is Cl minus. Right? And what are the products formed? Na in the solid state. Yes, it is deposited and chlorine gas will be liberated. So these are the two products which will formed. Sodium is deposited in the cathode and chlorine gas is liberated in the anode. So I hope it is clear. So now in this case there was no much confusion because there was only sodium, Na plus and Cl minus ions. From sodium underwent reduction and formed Na and Cl minus underwent oxidation and formed chlorine gas. So this is clear. Now moving on to the next one, that is electrolysis of aqueous sodium chloride. Aqueous sodium chloride means what is the difference between molten sodium chloride and aqueous sodium chloride? In aqueous sodium chloride, apart from sodium chloride, water will be also present. Okay, so now what happens is there will be a competition between the ions, that is which products will be formed. So that means in sodium chloride, Na plus and Cl minus ions will be there. Other than that, it is aqueous sodium chloride, so water is also present, hence H plus and OH minus ions will be also present. So there will be a competition between the ions now. So as you can see here, during electrolysis of aqueous sodium chloride solution, right, the products are sodium hydroxide will be formed, chlorine gas will be liberated, hydrogen gas will be also liberated. So there are a total of 3 products here. And in this case, besides Na plus and Cl minus ions, we also have H plus and OH minus ions from the water. Why this was not present in molten sodium chloride? Because there was no presence of water there. Now it is aqueous sodium chloride. So a total of 4 ions are there. Na plus, Cl minus, H plus and OH minus. Yes. So now there will be a competition between Na plus and H plus. Who is going to get deposited or who is going to get liberated? Same way OH minus and Cl minus. Right. So let us see based on which factor we will decide which products will be formed in the anode or cathode. Let's see. At the cathode, what reaction takes place? Reduction. At cathode, there is a competition between the following reduction reactions. So one reduction reaction which is possible is Na plus accepts electron and Na solid is formed. One reaction which we have already studied earlier also. Now one more reaction is possible, that is H plus ions accepts electron and forms hydrogen gas. Hydrogen gas will be liberated. So either it can be sodium which is getting deposited or hydrogen gas which is getting liberated. So now how do we decide which reaction or which product will be formed? Now this is based on the electrode potential, that is standard reduction potentials of this electrodes. Okay, standard reduction potential. So whichever reaction is having the higher reduction potential, that will be considered as the cathodic reaction. So as you can see, the first reaction is having the reduction potential as minus 2.71 volt, right? And the second reaction is having the reduction potential 0 volt. It is hydrogen, right? So it is 0 volt. So comparing these two, which one is having higher reduction potential? It is minus 2.171 and this is 0. So of course, hydrogen will be having the higher reduction potential. So always you have to remember, whichever electrode is having higher reduction potential, that will be considered as the cathode. So the reaction with higher reduction potential is preferred, and hence the reaction at cathode will be, yes, out of this two, this won't be happening. This reaction will be preferred. Understood? So sodium will not be deposited. It will be hydrogen gas which will be liberated. Clear? So this reaction will be preferred. So which will be the reaction that is happening there? Hydrogen gas will be liberated. So actually from where you are getting the H plus ions, it's from water, right? So this is the reaction that you have to be writing here. Water accepts electron. Don't write this one, that is H plus accepting the electron. It is water which accepts the electron and forms hydrogen gas and OH minus ions. So hydrogen gas will be liberated at the cathode. So this part is clear. Now moving on to the oxidation part. In the anode, what will happen? Again, two reactions are possible. So the first one is at the anode, the following reactions are possible. First one is Cl minus gets oxidized to chlorine gas. Right. Another possibility is water gets oxidized to oxygen. Okay. Two reactions are possible. Either chlorine gas is liberated or else oxygen gas is liberated. Okay. So now again, which reaction will be preferred? Now again, it is based on the standard reduction potentials. So now we are going to consider which will be the anodic reaction. So whichever electrode is having the lowest reduction potential will be considered as the anode. Okay, so when we are talking about cathode, the higher reduction potential one will be the cathode and the lower reduction potential one will be the anode. Okay, so now compare these two. Yes, one is 1.36 volt, the second one is 1.23 volt. Okay, so now out of these two, which one should be preferred actually? It will be the second one. Lower reduction potential is for the water. Yes, so hence that must be preferred. There is a small problem that happens here is on account of over potential of oxygen. We discussed about it in the beginning as well, right? It is kinetically very slow reaction, so over potential is required. Hence, over potential of oxygen is required. Hence, the other reaction is preferred. So, you have to be very careful. Even though the reduction potential is less for the water, still, this reaction will not be preferred because of the over potential of oxygen. So, which will be the reaction that will be taking place? Chlorine gas will be liberated, right? Thus, the net reactions may be summarized as, in the cathode, which reaction was preferred? Yes, water accepting electrons, and what is liberated? Hydrogen gas will be liberated. And in the anode, even though the reduction potential is high for it, why water is not this second reaction is not preferred? Because of the over potential of oxygen. That has to be remembered. So, chlorine gas will be liberated. So, overall net reaction, how can you write? This is the cathode reaction, this is the anode reaction. So, the net reaction will be NaCl plus H2O. Sodium chloride which we have taken, right? Sodium chloride in aqueous sodium chloride plus water, Na plus OH minus. Na plus and OH minus together will be forming the sodium hydroxide, right? Sodium hydroxide, and hydrogen gas and chlorine gas will be liberated. Okay, so here we already studied that it is hydrogen gas which is liberated, and now in this reaction we understood it is chlorine gas. Apart from that, also Na plus and OH minus ions is there, right? So that together forms NaOH. So a total of 3 products is there: sodium hydroxide, chlorine gas and hydrogen gas is liberated. So I hope you are clear with the difference between the electrolysis of molten sodium chloride and aqueous sodium chloride. Right? Okay. Now moving on to the next one, that is electrolysis of sulfuric acid, H2SO4. So during electrolysis of sulfuric acid, hydrogen gas is liberated at the cathode. Okay. Hydrogen, H plus ions, accepts electron. Okay. Accepting electrons, reduction which is taking place, and hydrogen gas is liberated, H2. Hydrogen gas is liberated. And at anode, two reactions can be possible. Okay. That is water getting oxidized to oxygen, right, and SO4 2 minus ions getting oxidized to S2OH 2 minus. So now in the cathode, it is only this reaction which is preferred, only one reaction. In the anode, two are possible. Now again, out of these two, which one will be preferred? For dilute sulfuric acid, the first reaction is preferred. So if we are taking dilute sulfuric acid, this is the reaction that will take place. That means oxygen will be liberated. Oxygen gas will be liberated, and at the cathode, hydrogen gas will be liberated. So the products will be hydrogen and oxygen gas when we are taking dilute sulfuric acid. But at higher concentration, that is concentrated sulfuric acid we are taking, means the second reaction will be preferred. Okay, so I hope this is also clear. That is the electrolysis of sulfuric acid. So I hope you are clear with the different products of electrolysis. So as I told you, it depends upon, that is when there are more number of ions present, which reaction will take place at the cathode and which reaction will take place at the anode will depend upon the reduction potentials of the electrodes, right? So whichever is having higher electrode potential, reduction potential, that will be considered as the cathode, and the lower reduction potential one will be considered as the anode, right? So I hope what and all we have discussed in this session is clear for you. So that's all for today. So in the next session, we will be discussing about the conductivity of solutions. So I hope the topics we have discussed in this session is clear for you. So that's all for today. Thank you.